in both questions. So let's take a look at the first one. It may answer the question for the second one. It's asking you first to look at this line. I mean, you have two independent lines here, and you're asked about their relationship. The only thing that dictates relationships between lines regarding parallel or perpendicular is what? What's the thing that determines if a line is parallel or perpendicular to another line? The slope. That's all you care about, right? Now we're going to graph these too, because I want to make sure you guys are comfortable graphing this since that's expected on your test. But really all you're looking for is the slope. X equals -2. What's the slope? Is it? Be very careful, because remember, the primary way I've taught you guys to look at a line is in this form. I've told you, especially if you're graphing, you want to have y equals and then something beside x plus something, right? Where m right here, this is your slope. So that's what we've been learning. Now be careful with this. It's tempting to say -2 because you're associating that number with your x. But when you look up here at this general form, the number with x is the one touching it. That's the slope, isn't it? When you're looking at an equation, you're trying to get y equals. Get everything else on the other side, then talk about slope. Do you even have a y in that entire equation? That should make a serious red flag go up in your mind. Hey, I have x equals -2 and I can't write it the way I like to write it. That's not my slope. That's a funny line. That's the one where the guy falls off the cliff. That's the line where the slope is undefined. Let me graph it for you. We have no y value, but we know that x is equal to -2. So here's my x-axis, my y-axis. 1, 2. So at -2, we know that we have that value always. That's what x equals -2 looks like. It's not a matter of what is the slope. The slope's undefined. Remember, we said that a telltale way for you to deal with that, for you to look at that, is to remember the guy on the cliff, right? Sometimes it's walking uphill, sometimes it's walking downhill or on flat land when it's 0. But when it's like this, he's falling because it's undefined. It's not a good situation. There was no y to begin with in our equation. Y is the most fundamental variable we have to have in these, or something that's playing the role of y, of our output. In this case, we only have our input equal to something. Okay, so we've crossed that one to look at it. Then it says, is it perpendicular to y equals 3? This is kind of a challenging one. I mean, yeah, the slope's undefined, but next we have to ask ourselves, well, for y equals 3, what's that slope? This one does have a slope, doesn't it? I mean, we don't see an x, but if I don't see an x, what does that mean about the slope? It's 0. There is one. It's a happy equation. It is an equation because I have y equals something. But there's no slope because there's no x. So again, our equation y equals, we satisfied that, but we're not seeing an x. And the way that I notice Kel likes to write it is he tends to do this. He probably would have written plus 0x. I've seen him doing that when he calculates his slope. That's an explicit way of saying no x, none of that variable. Do I have to write plus 0 ever? No. It may have been the y-intercept you wrote, but I've seen you putting the plus 0 on there. And the point is, they don't have to show you that. They're expecting you to say y equals mx plus b. That's my general form. If any piece is missing, that piece has to be 0. It's not there. So our slope is equal to 0. And this is a very cool critical exercise because we have to go further than just saying slope equals 0, slope equals undefined. This is the first example we've seen where we've talked about how does undefined compare to 0. So let's graph it. Y equals 3. 1, 2, 3. And this time it's a flat line, isn't it? Exactly flat going side to side because slope is nothing. So in blue here we have y equals 3. Talk to me, guys. Are these intersecting at an exactly 90-degree angle? Are they making a perfect square in the corner of how they hit? Oh, yeah. What a neat case. Special case. I didn't even think of showing it to you last time, so I'm glad you saw it in your homework twice. These are perpendicular. You probably, at least for the first time, it was good that you graphed it if you did that to find the answer. In the future, you can remember undefined and zero are the exact opposite ideas. Remember that perpendicular is opposite opposite. The slope is completely different. Normally it's negative reciprocal or opposite opposite. In this case, slope equals 0 and slope undefined. That is opposite opposite, guys. That's the same idea, okay? So the next one I asked you, that's basically the same thing. You probably already know the answer, but we'll work through it anyway, just to make sure we're all on board. X equals -3. Talk to me about the slope on this. Is it 0 or is it undefined? How do you know? There's no y. That's the red flag. If I can't make it look like this equation on top, red flag has to go up. That's what's happening here. Slope is undefined. And I can't write the whole word. I put UNDEF for undefined. Now for the other line, y equals 1/3. We do have a y this time, but we have no x, do we? Because slope is equal to what? 0. It's flat. Let's graph this thing. Technically on the axes, I should be putting arrows because we know that the axes count out forever both directions. I just get a little lazy with that sometimes. So know that when you see that, it is standard to show that the lines go forever. Okay, so the first line, x equals -3. 1, 2, 3. We'll draw a line. Oops, x equals -3. When we were graphing it, I mean, at least we knew it's going to be one of the straight up and down ones. We knew it was one of the ones that didn't pass the vertical line test because there was no y. That can help us reason through what's going on, right? Well, the way you can remember that it does that is because of the fact that you have x and no y. Now, I can help you reason through that in just a second, okay? We'll do an exploration in a second to help make that more concrete for you, okay? But as far as just remembering, remember it's because this thing is not defined. It's going to be vertical because that's what makes it fail the vertical line test. That makes it not a function. And we knew that because there was only an x. Now for the other one, it's the opposite. It's not going to go straight up and down. It's not going to fail that vertical line test. It's going to instead go side to side but be flat. And what's its height? What's y equal to? Okay, so here's 1. I'll say 1/3 about here. Really close to that line. Are these perpendicular, parallel? What's up with these?
Parallel.
Yeah, I can hear you. So these right here are perpendicular in both examples. When you have undefined and 0, you have perpendicular. Do you have a question online?
Nope.
Okay. Let me know if you have one, okay?
Okay.
Okay, now let's look closer. Cal asked a good question. He said, wait a second. If you have x equals -3, yeah, it's great that you're telling me that's a vertical line, but maybe I'd like to make it a little more concrete for myself. Let's remember how functions work and how we can generate pictures. We can use tables, right? Oh, okay, let's make a table. X and Y. Let's see. We know X is always what? -3? Okay, that's important. Pick the Y value for me, because we already know what X is. Okay. Whoever has their mic on, could you please fix it? It's hurting my ear. Thanks. Let's make some values for Y. How about 0? When Y is 0, what's X? So look at the equation. Okay, -3. When Y is 1, what is X? Wait a second. Why is it -3 both times? There's not even a Y in there. When I go plug it in, it doesn't go anywhere. I just keep -3. Okay. When Y is 5, what's X? How about a -2 for Y? What's X? Isn't it weird that even for the table of this thing, I have to think about it backwards? I mean, normally you would use x as your input, wouldn't you? Normally I would have been making up these values and generating my y's. I mean, yes, you can go both ways. You guys have practiced that with your intercepts. You can put in a y or an x. But even the way we had to think about this one was so funny because it gave me only the x's. I had to generate those y's. But every time I tried to plug in a different y, when I look up here, I can see there's not one. It doesn't change my x. There's no y in there. Good observation. Let's graph this now. Again, you only need 2 points to graph a line, but I wanted to make sure that we were seeing it obviously here. X and Y. I'm still having problems with that. It's okay. Let's see. When x is -3, 1, 2, 3, y is 0, so I got a dot there. When x is -3, y is 1, dot. When x is -3, y is 5. 1, 2, 3, 4, 5. When x is -3, y is -2. Huh. Do you see the pattern? Doesn't matter what y is, x is always the same thing. So what I end up getting is something that for every single possible height hits at x equals -3. You don't have to regenerate this picture, but just understand that's why it's happening. And likewise, when you're looking at y equals something, it's because the x's aren't changing. Just like I generated this one using different y's, if I had y equals 1/3, for every single x I put in, y would have still been equal to what? 1/3, right? Okay. That's why you're just getting straight lines going straight up and down or straight side to side. This one's the tricky one. There's no y in there. That's the one that's supposed to make your head hurt a little. It's not a function, is it? Even before I drew that line, it failed the vertical line test. Just a few dots I put on there. It's not a function. Nothing about it plays the way it's supposed to. It's undefined. Good. Versus the other kind that I just referred to up here in blue, y equals 1/3. That one is a function. Sure, there's no slope showing, so we have a y. We have an output that's always 1/3. So that's why here you're getting something friendly, something going side to side. Again, remember on this test, guys, you only have lines to deal with. You'll deal with some relations in the beginning where you have dots, but as far as when you're graphing things, the kind of pictures when you connect the dots, will be lines at the end of the chapter. Other questions or comments before our quiz? And the quiz is just for the seated group.
Yeah, work out.